It's not uncommon in a project to need to do a widening, and this could be to accommodate a bus bay or a parking bay, or it could be to edit some other code and change the way the cross sections are shaped. Traditionally, that has been achieved by either applying a number of what we call linear variations, or else creating a polyline or an alignment to describe the geometry of a bay. In this case, what we're going to do is to leverage a custom variation. So if we open up the variation list and we go to custom variations, we have a custom variation here called modify a bay widening. So what this is about is it's about transitioning to a change in width, maintaining that width for a distance, and then transitioning back. What we do is we pick a start point. So the start position is important, but the end position is not. So what you're doing is really picking where the bay or the widening starts. After that, you pick a code to widen, you pick an extra width you would like for your bay, and then you proceed to look at the geometry of the bay. So what is the length of the taper coming in? What is the method of doing that taper? So linear is very traditional, direct line from point to point between, in this case, 60 and 75. A bay taper will do an arc, a tangent, and an arc at third positions along the length of the taper. So for the first 5, it would be an arc, next 5 it would be a taper, last 5 it would be an arc again. And reverse parabolic essentially creates back-to-back curves. The other 4 are probably more useful for rail type scenarios. So what we're going to do is we're going to pick linear for the start. You also then have a bay length. So what is the length of the parking bay or bus bay? The taper to return, so we're talking about the northern end in this case of that bay, and then a method. So we'll go with reverse parabolic for the return. You also have the ability to add additional spacing. So this is important for sampling to increase the fidelity of the calculations. I'll turn it on in a moment, but if I click on add update, what we'll see is that that widening goes in. Okay, so you can see here that it's tessellated against the cross sections. So what I'll do is I'll tick on to add extra sampling, and then once I update that or hit recalculate, the software will apply that spacing. So what we see out of that is a finer result. Okay, and hitting rebuild models will force it to update the surface information related to that change. But what we can see when we have a look is that as we sort of roll through in the cross sections from 60 up, we are widening out to that extra width. If I refresh the model here, I can then see that bay in, and I can see that extra sampling. So I've got a linear bay at the front there. So what I'll do is I'll change that rule, and I'll change it from a linear to a bay taper. So this will be arc, tangent, arc. Once we apply that, we'll be able to see that happen in the plan, and we'll also be able to see it happen in the model. So I'll just refresh the model. So there you have it. That's what it takes to create bays that have a defined taper